Computer Science and Information System at BITS Pilani, Hyderabad. He is currently leading a project on multi-NAC networking test bed for the drone communication funded by DST SERB by the Government of India. Previously, he has been involved as a work package leader in the two European space agencies. He was a member of European Cross Action from 2013 to 2016. Due to the PhD from UAP, Spain, he was awarded a UAP Doctoral Fellowship grant from 2011 to 2015. Post PhD, he was fortunate to spend a few years at Tech Norway as a senior researcher from 2015 to 2018. Prior to his graduation, he was awarded with NTSC scholarship India where he secured overall 11th rank in the country. So now I would like to hand over the session to Paresh Saxena sir. Thank you, sir.
Okay, so first of all, I would like to thank KMIT management and also Prabhu sir to invite me here and to give me a good opportunity to present in this workshop. So just a brief background, thank you for the ma'am to introduce me. So I'm coming from BITS Pilani, I'm an assistant professor there in computer science department. I have a team of 6 to 7 PhD students who are working in different areas, mostly looking into the applications of something called as reinforcement learning, which I would like to introduce here. We are of course I'm teaching subjects in these areas, but I'm doing some extensive research as well. So I think the students of KMIT who are interested or anyone else who is interested in pursuing their PhDs from BITS, feel free to write me. My email address is here and my web address is also here, so you can look into my publications and the research that I have been doing. I did my PhD from Barcelona in 2015, and in 2018, from 15 to 18, I was working in Oslo, Norway for 3 years in the European Space Agency projects, and then 2018 I joined BITS. So I have roughly 4 years in academia, comparatively newer in this field. So let me start with this. I will take the applications of deep reinforcement learning for cybersecurity. Reinforcement learning is in a way is a very new field. It's a category of machine learning. I will explain you that as well. But it's very upcoming. In recent 3 to 4 years, we see the number of publications and researches happening in this area is much more than what's happening in supervised or unsupervised learning in different domains. Okay. So this is the overall outline. What I am planning to do is that I will take a brief introduction of the reinforcement learning technique itself, and then we will be looking into the applications of this technique into the cybersecurity. So a few slides on the reinforcement learning, which is a new learning technique or a different field of machine learning. Let's look into that first. So as you know that mostly you may have heard about the supervised learning and the unsupervised learning. Supervised learning is mainly the learning techniques where you have labeled images with you. Labeled images meaning, let's say you have an image, you have several images and you want to identify whether it's a dog or a cat. So labeled images meaning you will have the image and a label associated with it. The label is going to be whether it's a dog or a cat. You also have something called as unsupervised learning. Unsupervised learning is something which is where the labels are not present and you are trying to look patterns into the data. That is unsupervised learning. We are dealing here with the third field, which is the focus of this presentation, which is going to be the reinforcement learning. Reinforcement learning is something where you interact with the system, you learn from the system. It's a hit and trial approach, or it's like interacting with the environment and taking feedback from the environment and learning from the environment. It's very different from machine learning, from supervised machine learning and unsupervised learning, but it is still a part of the machine learning field because it involves a learning process. So just few examples. What you will see here, you have a person training a dog. If a dog is going to go and catch this disc, you will give some reward. Or if you have a class, you have a lecture, and you are asking a question, and if a person is able to answer that question, you will say, okay, you will score 1 mark or 2 marks, or you will get this something. You're getting something, some reward in return of the action that you are taking. This is the paradigm of reinforcement learning. You have rewards, you have actions, you have states. Everything in this world have certain states. Even if I'm planned to move down now from this stage, I have a state where I know that, okay, this is at this height, and then there are people sitting around me. My action is going to either bend my knees or not bend my knees. If I do not bend my knees and if I took that action, I will just fell down. Maybe as a kid I was doing that, I was falling down. But then I learned that, if I don't bend my knees, I will fall down, I will get hurt, and I will not get a reward. I will get a negative reward because I'm being hurt. Now when I bend my knees and I get down, I'm not falling down. So I'm getting some kind of positive reward because I'm doing something. That's what reinforcement learning is. You take certain actions and you learn from the actions. It's the same thing when you have a baby. The agent is baby, the environment is workspace, things around it, and then baby starts walking. It learns from the environment. It will fall sometimes. It will stand up, and it will learn from the environment. So I hope that we have established a very basic understanding of reinforcement learning, that it involves learning from the environment, doing some mistakes or not mistakes, and learn from the environment. That is what is reinforcement learning. Okay. So there are few questions or features of reinforcement learning. The first thing is what to do, how to map situations to actions, what are the actions, how to maximize the rewards. These are important questions. Learner agent is not told what to do the actions, unlike in supervised learnings. You don't know what action to be taking. If I'm going to walk now, should I bend the knees or not bend the knees, is something which I need to decide. You are not going to tell me. How will I decide? I will take an action, I will fall down, I will have a problem, and then I will learn from this. So I need to decide what action I need to take. Learner agent discovers the action with the goal of maximizing the rewards. So let's say from here, if you have to go to Secunderabad railway station, there are several ways to go through it. So maybe several different paths to go through the Secunderabad railway station. You will take different paths, try to, maybe the reward is going to be the time, so you will choose the path where you will get the less, from where you will take the less time. So that's like a reward which you would like to maximize. And there is also something called as need to explore and exploit. So that is also something which I am going to tell you while moving ahead with this presentation. So these are the key features of the reinforcement learning. There is also a concept, we will also see the example of it. There is also a concept called as exploitation and exploration. Should we exploit or should we explore? This is very important. It's there in the learning techniques, but we are also doing that in real life. We got a job, we are doing a job, we are getting some salaries. We are keep doing that job. We are exploiting the situation. We are keep exploit here is not in a negative way, but we are keep doing that job. We are not exploring something else. We are not exploring, maybe I do some higher studies or maybe I do some business. I'm happy with what I have, which can be good, which cannot be good. We don't know about that. But there is always a chance to explore. Some people take risks, they leave their jobs, they go for research, maybe they get success in that. They open their own business, maybe they get success in that, maybe they don't get success in that. But there's always something called as exploration and exploitation. So as a learning agent in reinforcement learning, you are planning to explore and exploit both. You have to maintain the balance in both of these things. Too much exploration is also bad, and just keep exploiting is also bad. I mean, that is some lessons that you can learn from your real life also, which is also implemented in the learning schemes. Just an example of exploration and exploitation. You see you have 5 doors here, and what is known to you is that there is 100 rupees in door 3 and there is 2000 rupees in door 5. That is something which is known to you. So you don't know what is between door 1, door 2 and door 4. You don't know that. The question is, you are given a 3 chances to open a door. Now these 3 chances, in one chance you can open any one of these doors. Now the question is, and of course the second chance you can open another door, the third chance you can open another door. The question is, which doors you are going to open in the next 3 chances? Anyone wants to answer that? What you are going to open in the next 3 chances? 1, 3, 5. 1, 3, 5. 3 and 5. Okay. So what's your name? Sahil. So Sahil has said 1, 3, 5, which is of course a good solution. Sahil is someone who is not going to take a complete chance to explore all things in the wild. But Sahil is also taking one chance to look at the one door, and Sahil is also trying, okay, please playing safe and having door 3 and door 5. He is making sure that at the end of the day he will get 2100 rupees. And then he will open door 1 where he doesn't know what he will get. He may get a big reward, he may not get a big reward. The thing is that this is all depends on your choice and how you want to play the game. Some of you may say that I will just choose door 5 and door 5. 3 times I will choose door 5. You are sure that at the end of 3 chances you will get 6000 rupees. That is for sure. Nobody will choose door 3 times because you know that it's only 100 rupees. But there might be some of you who would like to take chance and will open door 1, door 2 and door 4. Now, someone who is going to select door 1, door 2 and door 4 is doing complete exploration. Someone who is doing only door 5, door 5, door 5 is doing complete exploitation. This balance is very important when we talk about the reinforcement learning algorithm. You have to maintain between the exploration and the exploitation. So yeah, this is just an example. If you open all the 3 doors, you will earn rupees 6000, and let's say you just take a chance, you open door 1, 2 and 4, and maybe behind the door 4 there's a lot of money. You will achieve much better reward at the end of the day. That's also one of the possibilities. So far I was just trying to give you a brief understanding of this field. Let us go a bit deep into that. We will not have time to look into a more advanced algorithm, but still we will have time to take into some of the, to go a bit deeper into the understanding of this topic. There are a few things, something called as policy, reward, value function and model of the environment. Policy, what is policy? A decision which you like to take. In the previous slide, what is given to you is the state, that behind door 1 is this, behind door 4 is this, and behind door 2, 3, 5 we don't know. That was a state. The policy is, given that state, what action would you like to take? That's the policy. In reinforcement learning, when you are playing with the system, you are trying to learn that policy. You are trying to take an action given a certain states. Then reward is something what you are getting. For example, in the previous example, you are getting 2000 rupees or 100 rupees or a lot of money behind door 4. Then value function is the amount what you are going to get. The reward amount what you are going to get. And the model of the environment is the overall elements which are there in the environment. All of these things are important while formulating the reinforcement learning problem. Okay, so I'm going to get a bit more technical now. These are some of the algorithms which exist when we talk about the reinforcement learning. If you are interested, you can go through the book, Richard Sutton book, which is a Bible of reinforcement learning and introduction. This is like also a textbook which we take in bits as well. There are a lot of different methods. Some are called as value-based methods, which based on the values, Q-learning, SARSA, Monte Carlo. They all have their own mathematical background and also the way they are being implemented is different. Then there are policy gradient methods. We have reinforced, vanilla policy gradient, TRPO, PPO. Then there are actor critic methods as well. We have deep deterministic, DDPG, D4PG, A3C. All these are algorithms that exist in the context of deep reinforcement learning. So if you are interested in this field, you can actually go beyond and look into these algorithms as well. Specifically, every reinforcement learning problem can be formulated by this simple state diagram. When you talk about state diagram, you have the environment here and there is an agent. In the previous example where I show you the doors, the agent is you who was taking a decision what door to open, and the environment was what is presented to you, that these are the doors, these are the states, these are the rewards. It works iteratively. You take an action, you get a reward. You take another action, you can get another reward. At the end, what you want is to maximize the overall reward or overall cumulative reward. The cumulative reward is given by this. There is a Q function with respect to states and the action, and you have reward R, then gamma into RT plus 2, gamma squared into RT plus 3 and so on, where this gamma is a discount factor. This discount factor is important because when you are making a decision by considering several of the next steps, you want to depend more on the initial steps that you have taken rather than the steps that you have been considered few times steps before. Okay. So this is a common state diagram which has been used in the context of reinforcement learning, and anyone who is interested in this topic should be starting with this diagram as well. There is also one more thing. There is something called as model-free reinforcement learning and model-based reinforcement learning. So for the model-free learning, you can directly use the reinforcement learning methods, have the value and generate the policy. Policy again, what actions you would like to generate given certain states. Similarly, you have model-based reinforcement learning where you have the environment and where you also have the model. Some modeling is already existing of the environment. It's not something that we don't know anything about the environment. There is something which we know about the environment. We can take input from the environment, learn from the environment, and then we can update the model also which we are using to make decisions. So that is also different classifications of reinforcement learning. So I will now take one or two more slides to make you understand what is deep reinforcement learning. So as you know that we talk about machine learning and then deep learning. What is this deep component and why do we need the deep component? Why deep learning is being integrated? See, with any other machine learning algorithm, you have to obtain some classification or some regression or something at the end. You would like to obtain some policy or some value. If you see here, when we talk about complex environments, specifically where reinforcement learning is useful, if you talk about the complex environments, there's a big state space. There can be a lot of states. There can be millions of states which are possible, and there are hundreds of actions which are possible. You cannot have simple machine learning techniques or simple learning, some mathematical approximation to map these big state and action space to the final value, Q value, or the value function that you are obtaining. So you need a neural network to approximate your value function. This is just one example of how the deep learning can be integrated with the reinforcement learning. Okay. This method is also known as deep Q network. So in case you are interested in this field of deep reinforcement learning, you should look into the deep Q network, and then another one which I am going to explain is the actor-critic methods. Deep Q network and actor-critic method are two most prominent pillars of this field. Okay. This is another example of the actor-critic methods. What actor-critic methods are doing is the two things. First, you are doing learning in parallel. You are having different environments. Each of the environment is learning locally and then providing the updates globally. This is one benefit of actor-critic methods. The second benefit is that within each environment there is a game which is being played by the actor and the critic. As the name suggests, actor provides the policy, and as the name suggests, critic will give the value corresponding to that policy. They will try to update the weights, and all these weights which is updated by environment, environment 2, environment n will go to the global policy maker. Of course, this is happening within the one machine only. You are learning within the one machine itself. So this is something, these are also called as actor-critic methods. So actor-critic methods or deep Q network are the two most important algorithms in the context of the deep reinforcement learning. So if you are interested in this area, you should look more into that. You can follow the books written, or there are also several research papers in this field. Now moving forward, now come the applications of deep. So far it was important to give this brief background of the reinforcement learning so that you know what reinforcement learning is. You have states, you have action, you have the environment. So you can interact with the environment and learn your actions from the environment. Now there are these different fields of cybersecurity where deep reinforcement learning can help, okay? Including cyber physical systems, including malware. When we talk about the malware, we are also considering ransomwares as well. In the ransomware, you know that they will attack your system and they will lock your system until you give them the ransoms. That is also a very important field. Adversarial environment, spoofing attacks, game theory, jamming attacks, anomaly based detection, signature based detection, all of these different varieties of cybersecurity fields can be modeled as state, actions and reward, and then you can learn from the different various state actions, get some reward and learn what could be the policy which you should do. I will take a concrete example of two use cases, and then you will know better how the deep reinforcement learning is being used in these two fields. So one is the cyber physical system space. You see the cyber physical system space, you have CPS where you have a different, this is not very clear, but you have manufacturing, health monitoring, smart grid, all these are interconnected system. They may also have an external connection with the internet as well. There are some examples of cyber attacks in CPS. In 2015, I think the hackers attacked the control system of steel mill in Germany. They have obtained the login credentials by phishing emails, and not only it created a partial shutdown of the plant, but it also led into millions of dollar losses to the company. I think 2015 December only cyber attack was there on the power grid in Ukraine, and it disrupted electricity supply to a few hundreds and thousands of end consumers. So cyber physical system is of course a very important aspect of the whole cybersecurity domain, and there these different applications which exist, they can be attackers can launch sophisticated attacks on these systems. So if you see a system model here, you have a cyber attack, you have a cyber layer, you have physical layer and disturbances. You can obtain the states from the physical layer, whatever the conditions are there in the cyber physical system, and then you can use your cyber defense, for example an actor-critic algorithm, a deep reinforcement learning algorithm, to safeguard your system. This is again taken from this figure is taken from the paper. So if you are interested more into how DRL is being integrated there, this paper is there in 2017. I have also mentioned the reference of the paper. Now the last example, this is our own paper. One of my PhD student has presented it in July 2022 Italy in the CEC conference, this IEEE conference. What we have looked into is, so we have a system, let's say an Indian government has a big server setup and maybe the China and US all are launching attacks. And there are also benign activities happening, benign meaning the normal activities happening at the system. How you identify that the attack is happening is via alerts. There are alerts which are being generated. Now the alerts can be due to benign activities, benign meaning the normal activities of the user, or the alerts can be because of the attacks that has been executed through these different attack agencies or different sponsored attack agencies. Now there could be hundreds and thousands of these alerts which may be generated in your system. And what you need to do is to optimize the way by which you can identify the alerts which are caused due to the attacks and do not consider the alerts which are caused due to the benign activities or the normal activities. In this case, this is, sorry for the print, I mean this is of course not very clear. I just have this algorithm that if you follow this paper, it's available on IEEE. We have proposed this DRL based algorithm where we have implemented DRL on the detection environment that is actually taking the inputs of what the attacks are happening and what the alerts which are being generated from the benign users, and it is actually prioritizing the alerts which are caused by the attackers, not by the benign activities, using this deep reinforcement learning method. So these are some results which we have received. We have, okay, this is not very clear here, but these are the comparison of different algorithms that we have done. The details are there in the paper, and we have seen that some advanced deep reinforcement learning algorithm can actually give you benefits to provide the better detection system in such IDS systems. So just a last slide for anyone of you who is interested in the future research direction in this field. From the point research direction, the deep reinforcement learning, so this is not specifically related to the cybersecurity, but in general, if you are interested in the reinforcement learning or deep reinforcement learning, you can actually go and look into the on policy and off policy methods. You can see what are different off policy actor critic methods. You can go and learn what is TRPO, GA3, PPO, all of these keywords and key algorithms in this topic. Lot of research is happening in this topic. Any one of you is interested in this, they should go into that. Then there is also on policy actor critic methods, where including SAG, TD3, distributed SAG. So whoever is interested in the off policy or on policy methods, you can follow that. Now, from the research directions in cybersecurity, the applications of DRL in cybersecurity, there are various emerging CPS and DRL applications, the environmental monitoring application, electrical smart grid, transportation management network, all these are very much open areas where you can implement sophisticated DRL algorithms and see what are the advantages. There are also research on developing a live environment and proper interactions between the DRL agents and the IDS systems. And most of the focus now is on the host-based and network-based IDS systems with the integration of the DRL techniques. So to conclude, what I have presented here is a very emerging field which is called as reinforcement learning and deep reinforcement learning. It's a part of the machine learning only, but it's very new, so that whoever is interested from the job or from the research point of view, they can focus on that. And then of course, their applications and the impact of this field in this cybersecurity space. So that is from my side. Thank you very much.
Thank you, sir, for sharing great knowledge on the right way to apply the deep reinforcement learning for the cybersecurity. I'll ask you, sir, to do the demonstration for Sri Paresh Saxena, sir.
The higher dimensional space.
Right. Right. Higher dimensional space meaning there are states. So if I'm seeing this environment, currently this environment is there are, let's say 20 different people who are attending this. Now everyone is behaving in a different way. You might be sitting like this, you might be sitting like that, somebody is walking, there are so many activities happening only in this room. Each of this activity is one dimension. Now there can be multiple activities that are happening in this room. Activities meaning the number of states could be in terms of 1,000 or 10,000 or million, that kind of number. So it's not that easy if you just look for the small. So if you have a problem where you just need to take a decision looking into the time, my watch, okay, it's time to go or time not to go. That's a two-dimensional space. But when you see all of the different activities that can happen, that can contribute to the multi-dimensional state space. And you need solutions like deep reinforcement learning or in general deep learning. Deep learning is mostly specific to the multi-dimensional space.
That was wonderful.
Thank you, sir. Thank you.
Appreciate it.
Thank you, sir. Thank you very much, sir. Thank you.
So honored to have you.
Thank you, sir. Thank you, sir. Thank you.